This is Unit 4, Block 2. We're doing Example 3. So Part A asks us to find the general antiderivative of this third degree polynomial. Remember, a general antiderivative will have the plus c in it. We're looking for a function that when you find its derivative will give you a derivative of 5x cubed minus 4x squared minus 7x minus 9. So we first look at 5x cubed. I copy the 5 out front. And then I ask, what function would give me a derivative of x cubed? It must have come from x to the fourth divided by 4. So overall, it'd be 5/4 x to the fourth. Similarly, we copy the 4 out front for the second term, and if the derivative is x squared, it must have come from x cubed divided by 3. We copy the 7 out front for the first term, and if the derivative is x, it must have come from x squared over 2. If the derivative is minus 9, we get 9x. And don't forget, it's a general antiderivative. We always have to add c, because the derivative of a constant term c is 0. Next, it asks us to find a specific antiderivative of that same function if we know that f of 5 equals 20. Notice that's capital F of 5 equals 20. And over here, they defined for us that we're finding a specific antiderivative, capital F of x. So this added piece of information that they've given us is telling us a point on the antiderivative function. So in part A, we'd already found the general antiderivative. Now we can say that when x is equal to 5, we know that the y is equal to 20. So I take that general antiderivative function, I let x be 5, while at the same time letting the y equal 20, and then solve for c. So I take that general antiderivative, plug in, x is 5, y is 20, pull out my calculator or plug it in Excel. If you pop x equals 5 into that right side, you'll get 482.112. And that's 20 equals 482 and 112 plus c. Subtract on both sides to solve for c. You'll find c is equal to negative 462 and a 12th, or if you want to write it as an improper fraction, you get negative 5545 over 12. There's your specific antiderivative. The derivative of this function is the 5x cubed minus 4x squared minus 7x minus 9. And in particular, this particular capital F of x function passes through the point 5, 20. Approximate the value of this definite integral if we want to use 100 rectangles. We're going from x equals 3 to x equals 7 using 100 rectangles. So first I note that the length of this interval is 4 units along the horizontal. And I want to chop that length of 4 into 100 equal pieces. So I take 4 divided by 100. That tells me that each rectangle will have a base of 0.04. I then open up Excel. I create x values spanning from x equals 3 up to x equals 7, and they span a length of 0.04. So 3 to 3.04, 3.04 to 3.08, and so forth, all the way up to x equals 7, because the definite integral was spanning from 3 to 7. In column B, I put the rate function. Notice the rate function is this function that we are integrating. We're integrating 5x cubed minus 4x squared minus 7x minus 9. So that is the function that I've put in column B. Finally, in column C, we need to find the area of each of the little rectangles. Each rectangle has base length 0.04 times its height of each rectangle, which is found in column B. So 0.04 times the function height from column B. And finally then we do the left sums, the right sums, and then the average of the two. Remember, when you're doing a left sum, you're finding the areas of all the rectangles except the very last rectangle. And when you do the right sums, you do all the areas of all the rectangles except the very first rectangle on the left side. And you can use the average function in Excel to calculate the average of those two sums. So finally, coming back to this, my left sum from Excel was 2274.9. My right sum was 2330.6 and the average was 2302.7. That is my estimate of that definite integral value. Now we can actually use the fundamental theorem to calculate the value of that definite integral. Remember, to use the fundamental theorem of calculus to calculate a definite integral value, you find that antiderivative function and you can let the c equal 0. So here's my antiderivative function where c is 0. I then evaluate that antiderivative function at x equals 3 and x equals 7. So here it is evaluated at 7. Minus, here it is evaluated at 3, and you subtract the two to see how much that antiderivative function increased or decreased on that interval. So evaluated at 7, you'll get 1847.333 minus it evaluated at 3 is negative 455.333. When you subtract the two, you get 2302.667. So it's really 2302 and 2/3 if you calculated it exactly. That's pretty close to what we found in part C when we used 100 rectangles. Lastly then, the problem asks us to consider what all of this means graphically. So we integrated this rate function, f prime of x, this third degree polynomial. And if you think about that rate function, here it is. It's a third degree polynomial. And from x equals 3 to x equals 7, it looks kind of like this. And when you're calculating that definite integral from 3 to 7, you're finding the area between the x-axis and that rate function. Turns out that area is 2302 and 2/3. And we found the antiderivative function, capital F of x. That capital F of x function, it increases between x equals 3 and x equals 7. It increases a total of 2302 and 2/3.